Hi everyone, welcome to video 11-3A. We are starting our unit on similar figures and we are on page 601 in your textbook, your new volume 2 of your textbook, and we're in section 11-3, talking about corresponding parts of similar figures. So in a previous section we had talked about corresponding parts of congruent figures, and that was our CPC-FC little shortcut. If you're looking at your I-CAN statements document linked to your outline, remember, we're not talking about CPC-TC anymore. We're going to be talking about a new little acronym called CSSF. and the 5 cancel each other out, so this also becomes 1/2, you guys. The rest of the distances are much easier to just count our blocks on the grid. So CD is going to be 4, MN is going to be 8, and look, that's 1/2 as well. If we reduce that fraction or simplify that fraction, AD is a length of 6, KN is a length of, from again, -8 up to 4 is 12. So notice that every single time we are doing a simplification of ratios of corresponding sides, they all come out to the exact same ratio. And so this is what we call proportional, because we can pair any two pairs of corresponding sides and get the same exact value. That's called a proportion. And just so that you guys are aware, notice every single time we've been writing the proportion, we want to make sure that we are keeping consistent numerators and denominators. Meaning, if my numerator is coming from side lengths of the smaller figure for the first fraction, then for all of the other ratios that I do, I should keep the numerator consistent as the smaller figure, or vice versa. Depending on how I start, that's basically how I want to continue. So that's the first idea. This figure, then we would say, is yes, they are going to be similar figures, and that is because all corresponding angles are congruent and all corresponding sides are proportional. Okay, so let's go on to the next page. On the next page we have another pair of figures that we're trying to figure out. Are these two figures similar or not? Now, they're both rectangles, so we can easily, I think, realize that all 8 angles are going to be equal to 90 degrees. So yes, all corresponding angles are congruent. Now what we're going to do is we're going to go through and establish what are the ratios of the sides. Notice as we're looking across these ratios that are set up for us already, AB, BC, CD, and AD, all 4 numerators, are going to be coming from the smaller figure. And notice all the denominators, EF, FG, GH, and EH, are coming from the larger figure. So let's just keep that in mind, that again, we're keeping our ratios consistent as far as the source of numerator and the source of denominator values. Okay, so for AB, we can go ahead and again notice our scale is by 2, so we have 4 blocks times 2, or 8 for AB. EF is going to be 7 blocks times 2, or 14. If we simplify that fraction, that is 4 over 7. If we look at BC to FG, BC's distance is 3 blocks times 2 each, so that's 6. FG's distance is 5 blocks times 2 each, so that's 10. If we simplify that fraction down, then we have 3/5. Now we can go ahead and find these other ratios, CD and GH, but actually, you guys, we can stop right here because we gotta know. These ratios are not equal, and so we would say that these corresponding side lengths are not in proportion. Because we got 4/7 and 3/5, we can find these other values if we want to very easily, and again just by counting. But as soon as we get a no, are the figures similar? We would say no, the corresponding sides are not proportional. Now, if you guys remember on your most recent quiz where you were doing triangle inequalities and you were answering a yes or no question about whether triangles are able to be formed by a triple of sides, in this case, just like there, you need to provide some mathematical work to back up your yes or your no. So I would be looking for you guys to give me the ratios 4 to 7 and 3 to 5 and show me that, of course, those are not equal ratios. Okay? So we're going to skip ahead to page 603 next. And on page 603, we are going to practice filling in missing pieces of the proportions that we are given. So for properties of similar figures, we've already established this from the beginning, but corresponding angles of similar figures are going to be congruent, but corresponding sides of similar figures are proportional. And there, you guys, is our acronym that I told you about from the beginning, CSSFP. So just so that you know where that acronym is coming from, it's just a reminder that corresponding sides of similar figures are proportional. So that's what creates me the same size, or excuse me, the same shape, but just possibly different sizes. That's what similar means, okay? So again, we're going to try to fill in the missing parts of the proportion. Let's just skip down to B, and I'll show you how that's done really easily. It says in example 1, we're identifying what the properties of similar figures are, and we're kind of filling in the blanks here. So first off, we're told that in part B, figure JKLMN maps to figure TUVWX by some sort of transformation. You guys, that's just a fancy word for they're similar, okay? Write a proportion that contains both TX and LM, and then list any angles that must be congruent to angle V or to angle K. So the first left-hand side of our proportion here says that TX is down here in the denominator. So I'm going to go over and underline my T and my X, and that's the first and last letter. So that is the second figure's name in the denominator. So the first figure's name that corresponds to that is J and N. So we'll write that in. Then for LM is the third and fourth letter, and so that's going to correspond to the third and fourth letter of the second figure. So we'll have VW down here. And then again, we're just going to find the corresponding spot of those two statements. So what angle is congruent to V? Well, V is in the middle spot, and that's going to be, of course, L. And then what is congruent to K? K is going to be in the second spot of the first figure, so the one that's in the second spot of the second figure is capital U. Pretty simple, I hope, filling in the missing pieces of the proportion. You need to, again, know that this is figure 1 in the numerator and figure 2 in the denominator, and to keep that consistent on both sides of the fraction, both sides of the equal sign in both fractions. All right, let's move on. All I want you guys to do on this next page, page 604, the only your turn you're looking at is number 6. We're skipping over number 5. So I'd like you to do problem number 6, and that is checking in on, it's an error analysis problem, so you can suspect and anticipate that the proportion that they're giving you here is an incorrect proportion. What you need to figure out is what's wrong with it and maybe try to fix it. Okay? So that's all we're doing for this video. Is your turn, just the one number, and I'll see you guys in the next video, 11-3B.